Well, this is the filter end of the turbine. Some might say it's probably the most important part of the whole system, and indeed it's one of the biggest struggles to get right, and I had several attempts to try and get the system which I've got here. I was trying to do everything on a shoestring, and that's not always the best to go at it. So in the end I made a filter box out of 304 stainless. It's just got a couple of bits of coanda screen in it. It's just working very well. I had to bring the level of the water up. Originally there was a natural dip in the rock bed which I put a filter box into. I mean, that's still in place, and I use it for draining out if I need to do any maintenance or something. But the filter box was continually getting blocked up and clogged, and eventually that got clogged up with leaves and silt, and the pressure inside the pipe just sucked the sides of the filter box in. So another solution was need to be thought of, and this was it. You know, I had to bring the concrete up. I've put dry mix concrete into sandbags and carried them. I had to carry them about 180 metres up the stream bed. The sides of the ravine where the stream is are very steep, and I couldn't get access to bring any kind of machinery or anything to help me, so I carried everything up by hand and sunk rebar into the rock bed, fixed it in, and then skewered the sandbags on it, and then put the reverse face I've covered with concrete to make sure that all the bags are waterproof. It's a very good system, and it's working very well. I've got a little bit of silting, bit of an understatement really, on the far side of the weir. I don't know if this is going to make any difference. I'm thinking that maybe the water's going to take the path of least resistance, and the smaller particles will get filtered out by the filter box, and the larger ones will get deposited here only to be washed further down the stream. When we have a decent flood of water. From the filter box I've got a bit of 8-inch alkathene pipe, which nicks down to 5-inch for the rest of the journey, or the rest of the 180 metres down to the turbine. I made this piece out of 8-inch to slow the water velocity down in the filter box, so I didn't get too much of a vortex effect. And you can just see from the burn marks on the edge of the box where I've put some internal baffles down to hopefully break a vortex should one appear. There is a flange on the end with a 90-degree connection going on at this bit of 8-inch pipe. Well, this is the business end of the turbine, and indeed it is the turbine itself. She's a turgo turbine. At the minute it's running on 3 jets due to a bit of a shortening of water. It's a bit of a homemade design, utilising the ever familiar washing machine parts as they were often used. I thought about the design myself and constructed in my shed. It wasn't difficult to do. Luckily I've got a bit of a small machine shop and was able to make myself a bearing block and all the rest of the things in order to facilitate it. I've made a rather simple but effective way of mounting the turbine. I've just made a small plinth for it and chem-fixed threaded bar into the rock, which means that you can adjust it. Oops, sucking a bit of air there. Which means you can adjust the level of the plinth to get it level. The filter box is again made out, or the manifold block is again made out of the same 4mm stainless that the filter box is, and you can see that's got a flange connection on the end and splits the water into 4 ways, or potentially if the valves on the turbine were open. I think if I was to do it again, well, I don't think I know, if I was to do it again, I'd put the valves on the manifold block, because sometimes you need to do a bit of maintenance on the turbine, greasing, checking the lubricator, etc. And how it is now, I can't physically disconnect the turbine from the water I know I can do it by putting more camlock fittings onto the 2-inch connections which are coming out of the turbine to bring the valves further out, which is probably the easiest solution, rather than trying to mount them on the manifold block, which is probably a little bit too small for the purpose. At the minute she's running about 17 psi. There's not really enough water to run it. If I close the valve, she should stop sucking air and the pressure will go up somewhat. Up she goes then. Up to about 18 psi on 3 jets, but there's a bit of snow here and it's melting, so I'm hoping that as the snow melts, then that's going to provide enough fuel for the turbine to run successfully. Anyway, well, this is inside the powerhouse. It's really my clean workshop, and let's have a look and see what the turbine's making at the minute. At the minute she's doing 780 watts. Oh, there she goes. Yeah, give or take a bit. I'm very pleased with the whole affair. It's been a successful operation. Oh, a bit of a small mill. Oh, and a small lathe. Yeah, it's been a good, well productive operation. This is the first turbine that I've made. I've made 2 now. The other one's a Pelton. The other one's a Pelton turbine, running at about 50 metres of head, as opposed to the 15.2 metres I think that I've got, running about 4.5 litres a second, which has been another successful venture. Maybe I'll do a video of that later.